Is 329 a prime number? How to know it? How to find prime numbers between 300 and 400? So this type of question is asked in a mini competitive examination. So let us begin. Today we'll find how many prime numbers are between 300 and 400 and what are the short methods of finding it. So what we'll do first? First we'll go for even numbers. So even numbers are divisible by 2. What are the even numbers? And the unit place digit is 0, 2, 4, 6, 8. These are the even numbers and they are divisible by 2. So they are not prime. Because I'm not talking about 2, it is from 300 to 400. So first, these 302, 312, 322 all have last number 2 unit place digits, so they are not prime. Similarly, 304, 314, 24 up to 294, they are also even because they have the last digit 4. Similarly, 6 last digit is having this column 306, 316, 326, so on. Next, I hope you understand or you get a clue to get it. And last number is 310. So all these numbers are not prime. So we have shaded them, they are not prime. Then I'll come to divisibility by 5. If unit place digit is 5, then it is divisible by 5, or it is 0, then divisible by 5. 0 we already shaded, that means they are not prime. So unit place digit means 305, 315, 325, 350. So this line, all the numbers, 10 numbers are not prime. So I shaded with gray. So we finished 2, we finished 5. Then I will go for 3. How to find the divisibility rule of 3? You take any number, find the sum of the digits. For example, 301, the digits are 3, 0 and 1. I'll take the sum, I'll add them. It is 4. This is not divisible by 3, or this does not come in the multiplication table of 3. So 301 is not divisible by 3. Next, coming to 303. 303, 3 plus 0 plus 3, that will be 6. This is divisible by 3. So this number is divisible by 3. Next, what number divisible by 3? 306. Next, 309. That means you will add 3, or you can add them to find whether it is divisible. The sum is divisible by 3. Then 309. Then 3012 already shaded. 3015 already shaded. Or you can test with the free numbers. 317. If I add them, it gives 11 total, so it is not divisible by 3. Similarly, 319 is also not divisible by 3. Next, 321, 3 plus 2 plus 1, this sum is 6, so this is divisible by 3. Next is 324, it is already shaded. Then I'll come to this one, 3 plus 2 plus 7, 5 plus 7 is 12. So this is divisible by 3. This is not the prime then. Next is coming to 329. You will take sum 3 plus 2 plus 9. This gives you 14. So it is not divisible by 3. So this is not divisible by 3. Next, coming to 3, 3, 1. 3 plus 3 plus 1, 7. So it is not divisible. 3, 3, yes, it is divisible. There are 3 3's. Next, 3, 3, 7. 3 plus 3 plus 7, it is 16, not divisible. 3 plus 3 plus 9, this is divisible. Next, 341. 3 plus 4 plus 1, 7. Plus 8, not divisible. 3, this is not divisible. Next, coming to 347, 7 plus 3, 7, 7, 3 plus 4, 7 plus 7, 14, not divisible. 3 plus 4, 12 plus 3 plus 4, 7 plus 9, this gives you 16, not divisible. Then coming to 351, 5 plus 3, 8 plus 9, yes, it is divisible by 3. I'm rounding, I'm testing with 3. So this number is divisible by 3. Not divisible. 5 plus 3, 8 plus 3, 11. Not divisible. Next is 3 plus 5, 8 plus 7, 15. 15, 3, 5 times 15, so this is divisible. Next is 359, 5 plus 3, 8, not divisible. This is not divisible. 6 plus 3 plus 3, this is divisible. Next is 3, 6, 7. You will add them. It gives you 16, not divisible. 6 plus 3 plus 9. Yes, it is divisible. Next 3, 7, 1, 11, not divisible. 3 plus 3, 9 plus not divisible. 7 plus 7, 14 plus 3, 17. 17 does not come in 3 table. 3, 7, 9. This is not divisible. 381. 8 plus 3, 11 plus 2. Yes, this is divisible. This is not divisible. 387. 8 plus 3, 11 plus 7, 18. Yes, it is divisible. Next is 11 plus 9, 20. Not divisible. 3 plus 9, 12. It's not divisible. This is divisible. 3, 3, 9. Next is not divisible, and this is divisible. So all these numbers are divisible by 3. So let us shed it. So these numbers are divisible by 3. We finished by 3, then 5 we have already done. Next we will go for prime number is 7. For 7, I can take a rule to find the shortcut method, that is, you take the unit place digit, multiply with 2, subtract 8 from base number. If result is divisible by 7, then number is divisible by 7. So let us go one by one. That means 301, unit place digit is 1. If I multiply with 2, that is 2, then I'll subtract 2 from raised number. Raised number means 30. 30 minus 2 is 28. 28 is divisible by 7. 28, 7, 4 times 28. So 301 is divisible by 7. That means it is not the prime number. Next, I'll test for 307. 307 will not be divisible. You can apply the common sense because 301 is divisible by 7. So next divisible by 7 is 308, not 307. Or you can test with this rule. Next is 311. 311 you will test it. 311, 1 multiplies 2, so it is 33. 33 is not divisible by 7, so this is not divisible by 7. Next 313. 313, 3 unit place digits 6. You will add it, subtract it, it will be 24. 25, it's not divisible. So 313, 1. Next is 317. 7, 2 times 14. So 31 minus 14, it is not divisible by 7. Next is 319. 19 is 9 multiplies 2. 9 multiplies 2 is 18. 31 minus 18 is not divisible. In the same way, you can go for 323. It will not be divisible. 2 times 6. If we subtract, it will be 26. 26 is not divisible by 7. Next is 329. Let us take 329. I will write one by one so that it will be more clear. Next is we'll go for 329. 329. I have done 329. Then I'll go for 331. 331. 1 into 2, 2. Subtract 31. It's not coming in multiplication table of 7. Next is 337. 7, 2 times 14. No. Next I'll go for 341. 1 into 4, 4. 1 into 2, 2. So 34 minus 2, not divisible. Then 343. 343. 3 multiplies 2, 6. Subtract, you are getting 28 again. 28 is divisible by 7. So 343 is divisible by 7. Next is 343 plus 7 is 355. So 349 is not divisible. Or you can test here. Next is 353. 353 into 2, 6, 29, no. Next is 359. 9 multiplies 2 is 18. So 35 minus 18 is 17, not divisible. Next is 361. 361, 1 multiplies 2 is 2. 36 minus 2 is 34. It does not come in the table of 7. So 361 is not divisible by 7. 367. 7 2 times 14. You will subtract, not. Next is 371. 2, 35. It comes in multiplication table of 7. I repeat, 1 multiplied 2, 37 minus 2 is 35. 35 comes in table of 7. So 371 is divisible by 7. Next is 377 will not be divisible because already 371 plus 7 will be divisible. So 378 will be divisible by 7. So we won't try. Next is 383. 378 plus 7 is equal to 385. So 383 will no need of trying. Next is 389. 389. 9 times 2 is 18. If we subtract 18 here, you are getting 20. So this is not divisible. Next is 391. 391. 39 minus 2, 37, not divisible. Next is 397. 7, 14, 5, 2, not divisible. So let us shade now. So these four numbers are divisible by 7. 301, 30, 329, 329, let us check again. 3, because this number was asked in the beginning. 9 multiplies to 18. If you will subtract 18, you are getting 14. So 14 is divisible by 7. So 329 is divisible by 7. So it is not a prime number. So we have said it so many. So we finished checking by 2, by 3, by 4, 5, by 7. Then coming to 11. So what is the divisibility rule? This is the 3-digit number, 100 place, 10 place and unit place. You add these two numbers and find the sum, then subtract your tens place digit. If the result is multiple of 11 or result is divisible by 11, then the number is divisible, or if result is 0, it again divisible by 11. So but quickly you can test, you can find the number. Suppose 307, you will add 7 plus 3, 10 minus 0 is 10, so it is not divisible. Next is 311, 1 plus 3 is 4 minus 3, not divisible. So on. 313, 3 plus 3, 6 minus 1, 5, not divisible. 7 plus 3, 10 minus 1, 9, not divisible. 9 plus 3, 12 minus 1, let me write this number. 3 plus 9, 12 minus 1, so 11. So this number is divisible by 11. Next is this line, there is no such number. 331 you can test, not divisible. 337, 7 plus 3 is 10, 10 minus 3 is 7, is not divisible. Next coming to 341, 1 plus 3 is 4, 4 minus 4 is 0. So this number is divisible. Next, not divisible. 9 plus 3, 12 minus 4, not divisible. 3 plus 5, 3, 6 minus 5, not divisible. 9 plus 3, 12 minus 5, 7, not divisible. 4 minus 6, not divisible. 7 plus 3, 10 minus 6, not divisible. 6 minus 7, not divisible. 10 minus 7, not divisible. 12 minus 7, 5, not divisible. 3 plus 6 minus 8, not divisible. 12 minus 8, 4, not divisible by 11. 4 minus 9, not divisible. 7 plus 3, 10 minus 1, not divisible. So only two numbers are divisible by 11 in such 1200 numbers. So after 11, I will go for 13. So individually we can test, or first let us learn a rule so that we can get a short method. So take 3 digits, 100, tens and ones place digit or unit place digit. Separate this, multiply the unit place digit with 4 and add this result to this raised 2 numbers. If the sum is divisible by 13, if remainder is 0, then it is divisible by 13. I am taking the example. First is 307. The unit place digit is 7. I'll multiply with 4, 28. I'll add this number to raise the number, that is 30 plus 28 is 58. 58 does not come in the multiplication table of 13, or it is not divisible by 13. So the whole number is not divisible by 13. Next, 311. 1 into 4, 4. Add this 4 to here, so 37. So it is not divisible by 13. Similarly, 313, let us check. 313. 3, 4 times is 12. 31 plus 12 is 43. It is not divisible by this. So similarly, you'll go on checking all the numbers. 323, I'll check, no. Next here 331, it's not. 437 plus 4 is 37, no. 347, it will be 28, 62, no. 349, 36, 34 plus 36 is 17, not divisible by 13. 353, I'm individually doing in front of you. 343, 412, it is 47, not divisible by 7. 359, and not divisible by 13. 36, 71, not divisible by 13. 361, 4, 14, not divisible by 13. 367, 7, 4 times 28, this is your 64, not divisible. 373, 12, 49, not divisible by 13. 377, 28, 65, not divisible. Then 379, 36, this will be 73, not divisible. So you will be surprised to know so many numbers are not divisible by this. 383, I am coming. 12, it will be 50, no. Then 389, 36, 74, no. 391, 4, this will be 43, no. 389, 377, I think I have not done this one. 377, yes, this is divisible by 13. So I made a mistake here. 65 is divisible by 13. So 65 divided by 13 is equal to 5. So 377 is divided by 13. Similarly, I can test 397. It is not divisible. So only one number is there from 300 to 400 which is divisible by 7. So 377, I shaded with orange, that is divisible by 7. Next, 11, 13. So after 13, I'll come to 17. For 17, what is the rule? I'll multiply unit place digit with 5. Then subtract the result from rest. Rest means 100 place and unit 10 place. Let us take the example. 307. So I'll multiply 7, multiply 5, 35. I'll subtract 35. I cannot subtract, I am not getting 0. So this is not divisible by 17. Similarly, I'll go for 311. This will be 1 into 5, 5 equals subtract to 26. Then 313. 3, 5 times 15 equals subtract, you are getting 16. No. 317 735. No subtraction, not getting 0. 323, 15, this will be, you are getting 7 and 1, 17. Here I am getting 17. So 323 is divisible by your 17. Next, coming to 323 plus 17 is 340. So after 340, I'll see the again number. So I'll go for 347. 340 plus 17 is 357. So this number will not be divisible. 3 after 357, 359. Again you check this. 9 multiplies 5, 45. You are not getting 0. So 359 is not divisible. 361, 1 into 5, 5. You will add, it is 40. Subtract 5, it will be 31, not divisible by 17. Next is 367, 7, 5 times 35. This is 1, not divisible. Then your 373, 3 5 is 15. If you will subtract, you are getting 222, it's not divisible. 379, 9, 5 times 45, no. Next is your 383, divisible by your 12. If you subtract, you are getting 26. 26 is not divisible by 17. Next is 389. It's not divisible. Then coming to 391. 1 into 5, 5. Subtraction 34. 34 is divisible by 17. So 391 is divisible by your 17. So these two numbers are divisible by 17. So many numbers have gone. We have reached 17. Next is 19. For 19, what is the rule? Multiply unit plus digit by 2 and add to rest. If the result is divisible by 19, remainder is 0, then it is divisible. So let us take the example, or you can test one by one. 307 into 2, 14, add it, 44, no. Similarly 311. So if you will go on checking like this into 233, you won't be, this will also not be divisible by 19. 331 into 2, that will be your 2 added 35, it is not divisible by 19. Then 337. Whenever you are sitting in the examination, you are getting 2-3 numbers to test, not so much. So don't be impatient that it takes time, because we are taking so many numbers. 47. So you will go on checking all the numbers. You will find that only 361 is divisible by 90. So one number is divisible by 90. So let us shade it. So what are the numbers now? Now next, which number will test? No more checking. Why? Stop here. There are 23, 29, 31. All these prime numbers are there. We won't do it because last number is 400, which is 20 into 20. So don't go further. We will check up to 90. Whenever you are getting a number between 300 to 400, check with 2, 3, 5, 7, 11, 13, 17 and 19. For example, this question was 329. So it is not even number, not divisible by 2. 3, no. 5, no. 7, you will test in the ways. 7, 9 times 36, no. 11, 9 plus 3, 12. 12 minus 2, 10, no. You can text with 13. I have left 7, 1. 7, 9, 9 into 2, 18. So if we subtract 18, I am getting 14. So 14 is divisible by 2. So whenever getting individual number, you can go like this, not all the numbers. So how many numbers are there left which are not divisible by any of this prime number we have discussed? That is, your first is 307, 311, 313, 317. No number in between 321 to 30. This one, 347, 349, 353, 359. Thank you for watching the video. Thank you for having patience to listen to me. So these are the numbers for prime numbers. So 16 prime numbers are between 300 to 400. 307, 311, 313, 17, 31, 37, 47, 49, 353, 59, 67, 73, 79, 83, 89, and 97. So 329 is not a prime number. Now test your knowledge. Is 409 a prime number? If you are successful, comment me. Thank you for watching. Thank you for subscribing my channel. Thank you.